Hey viewers, welcome to day one of pre-calculus. A lot of this functions unit is going to be review from Algebra 2. So it's a great introduction. After this, it's going to be, most of the material will be completely new. So we'll start with functions. A relation is a correspondence between two sets. So if x and y are two elements in those sets, and if the relation exists between x and y, then we can say that x corresponds to y and that y depends on x. So let x be any two non-empty sets. A function from x to y is a relation that associates each element of x with exactly one element of y. So the set x is called the domain. And for each element x corresponds to a particular element in y that is called the value or the image. And the set of all images is the range. Okay, so the domain x, range y. So let's take a look at this example one. So for this relation, the domain represents four individuals. Here's your domain. And the range represents their birthdays. Okay? So, determine if the relation is a function. For every function, every x has to have exactly one y. And it looks like x has one y, x has one y, x has one y, x has one y. And just because Patrick and Phoebe have the same birthday, every time you look at Patrick's birthday, it's the same. It's the same. It's not a different day. Same for Phoebe. Every time you look at her birthday, it's the same. So every x has exactly one y. For this relation, we look at Maureen. Maureen's got two different phone numbers. So when you input x into this function, sometimes you get this phone number, and then sometimes you get this phone number. So Maureen has two different phone numbers. So this function, this relation is not a function because every x does not have exactly one y. So here is the practice, and I want you to, I should go back. I want you to pause, and I want you to see if you can do the examples and see if you can get the answers first. And then, of course, I'll show you the answers. So here we go. Pause, do the problems. Okay, so for every x, so here's your x coordinate and here's your y coordinate. X has to have exactly one y. Take a look at these two ordered pairs. Sometimes when you put a 2 in the function, you get a 5. Right? Sometimes when you put 2 in, you get a 3. So every x value does not have exactly one y value associated with it. So no, that's not a function. D does. For every x value, there's exactly one y. Every time you put in 1, you get 4. Every time you put in 2, you get 4. Every time you put in 3, you get 5. And then for E, when we put in -3, sometimes we get an output of 9, and when we put in -3, sometimes we get an output of 8, so that's not a function. So now we're going to talk about evaluating functions. So what we'll do here is f of 3. So we're going to take our f of x, and everywhere we see x, we're going to input a 3. Now you have to be careful because x is squared. You see that? So you have to square the 3. It's not too bad when it's a positive value. So 3 squared is 9, 9 times 2, and then minus 9, and you get 9. See if you can try the rest of these problems by yourself before I give you the answers. So press pause and then try them, okay? Now when you input a negative value, you have to be careful because this -1, the entire -1 is squared, including the negative. So that's a -1 times a -1, which is a +1 times 2. And then minus, this is a 3 times a -1, so that's a -3. So that is going to be 5. This is just 0. But you need to be writing this out. You need to be writing this first step out. So now a negative, shoot, I can't scroll. Hold on, give me a second. Oh, there's my Pikachu, ruining my computer. Good times. Why? It's fine. Everything's fine. Where's my flip chart? Why? Ugh, no way. It's fine. Everything's fine. Why did that? Do I have to start over? Okay, I didn't have to start over, but I lost a couple seconds there. It's fine. So when you have a negative in front of the entire f of x, we are going to rewrite f of x here. We're going to put a negative in front of it. Now we have to distribute that negative to every term. So each of those terms, the sign is going to change. So that's going to be a negative 2x squared plus 3x. And you're done. This is just asking you to evaluate. We don't know the value of x for d, so we're done. And then when there's a negative inside the function, you're going to be inputting a negative x everywhere you see an x. So this is 2x, and now it's going to be negative x squared. When you square negative x times negative x, you get a positive x squared. All right, we'll get down to the trickier one at the bottom here. All right, so x plus 3. So we have 2, here's our new x, squared, minus 3 times here's our new x. So we are going to have to FOIL this, or multiply x plus 3 times x plus 3. So that's x squared plus 3x plus another 3x plus 9. So that's where this x squared plus 6x plus 9 comes from. And there's a 2 in front of that. So now we distribute the 2. So we get 2x squared plus 12x plus 18. Now you have to distribute this negative 3 to each of these terms. So the signs will change. So that's a negative 3x minus 9. Now all we have to do is combine the like terms. And here's our final answer. Take a look at that. We're moving on. Okay, so when finding a domain of a function analytically, remember these rules. We cannot divide by zero, and we cannot take a square root of a negative number, okay? And input to logarithms, which we'll talk about later, it's got to be greater than 0. So when you're finding the domain of functions, you're looking for essentially a quote-unquote problem, okay? And that's either in the denominator or under a radical. In the first one, A, there are no problems, okay? So I can put any value I want in for x, whether it's negative or positive or 0, and I'm going to come out with a value. So my domain is all real numbers. If I write it in set notation, which is not really complete set notation, but that's fine. Or if I write it as interval notation, it's negative infinity to positive infinity. However, for B, if you look at we've got a denominator. So you're going to set the denominator equal to 0 because the denominator, we can't divide by 0. So let's see what values could x be to make the denominator 0. So we use our algebra. X squared minus 4 can't be 0. Solve and we get, all right, x can't be 2 or negative 2. It could be anything else. So we write that is, in interval notation, is negative infinity to negative 2 and not including negative 2. So we're putting a parentheses. And we'll talk about interval notation a little bit in class. In union with negative 2 to positive 2, but again, not including that 2. So we put a soft bracket or parentheses around that. In union with 2 to infinity. So again, we're not including that 2, so we put a parentheses next to it. For C, our problem is underneath the radical. We can't have a negative under the radical if we want to graph it. Okay, so we are going to set what's under the radical greater than or equal to 0, because we could put a 0 under the radical and we just have square root of 0 is 0. So I set 4 minus 3t greater than or equal to 0. Go away. There we go. Go ahead and solve it. Whenever you divide both sides of an inequality by a negative, remember the sign changes. So that's why the sign changes there, because I divided both sides by a negative 3. And then t has to be less than or equal to 4/3. So that means t could be anywhere from negative infinity up to 4/3, but it's including 4/3. It's less than or equal to 4/3. So the way we show it includes 4/3 is we put a hard bracket next to it. So that's how you write that. And we are almost finished. So operations on functions. Now we have two different functions. We've got an f of x and we've got a g of x, and we're going to combine them. based on what the problem says. So sometimes they ask us to add them. So that's f of g of x. That just means, sorry, so this just means f of x plus g of x. So go ahead and write this out. If you've got your notes printed, I prefer to write on paper. It helps me learn things. If you're just watching and you already know this, fine, but just keep in mind that you might not learn as much if you're not writing this down. So when I add these two together, I've got this right here, right? So I'm going to have to add these two fractions with different denominators. I'm going to have to multiply this denominator, or this side, by x minus 1 over x minus 1, and this side by x plus 2 over x plus 2. Now, when I do that, there is always parentheses around every numerator and every denominator. They don't ever write them there, but they are there, which means those are multiplied. So x minus 1 times 1 is easy. It's just x minus 1. And then my denominator, I'm just going to leave the same here. Okay, but now when I distribute this x, I have to make sure that I distribute it. So it's x squared plus 2x, and that goes here. Denominator is the same. Now I can look at the numerators and I can combine the like terms, and here's my answer. Okay, now if you can factor the numerator and cancel out a denominator, one of these denominators, great. Okay, but I'm not too concerned about that right now. We're just doing basics. All right, so f of x minus g of x. So go ahead and when you see this, we'll rewrite it as f of x minus g of x. So we're just doing the same thing, but we're subtracting. So I skipped the first step that I already showed you up here because we have to do the same thing, but we're just subtracting. So now we're at this term here where we're just subtracting, and you have to subtract each of these terms, this x minus square, or sorry, this x squared and also this 2x. So that's, just be careful about that, the signs, and take a look and make sure you know how to do that. When you're multiplying f of x times g of x, you don't have to worry about your denominators. You can just multiply straight across. 1 times x is x, and x plus 2 times x plus 1, and I just left it. And for the last one, we're almost done here. This means f of x divided by g of x. When you write this, you never divide by fractions. You always multiply by the reciprocal. So the first step, and you should be writing this out, is change. I changed division to multiplication, and then I flipped. And then I went ahead and multiplied. And then you're done, I think. Yes. All right, peace out.